Hi, this lesson is about introduction to limits. But before talking about limits, let's talk about functions and then we're going to introduce limits. Suppose we have a function f of x being equal 3x squared minus 2x plus 1. Now let's say we have f of 1. We're going to get 3 times 1 squared minus 2 times 1 plus 1. And in this case, we're going to get value 2, where 2 is defined. And the most important thing is f of 1, which means x equals 1. X equals exactly 1. So we can have 2, we can have 3, we can have minus 5, we can have minus 100, we can have any number. So we can pick any number on real line for x. Why? Because f of x being equal to 3x squared minus 2x plus 1 is polynomial, and the domain of this one is all real numbers. So x belongs to all real numbers. Therefore, we can pick any number. And there is no problem, and we don't need limits here. We don't need limit. So let me write another problem. F of x equals x squared minus 9 divided by x minus 3. So in this problem, we can say, for example, f of 1, we're going to get 1 squared minus 9, 1 minus 3, and this one is going to equal minus 8 divided by minus 2, and the answer is 4, because minus divided by minus is going to be positive. And this one is defined. And x in this case equals 1. Therefore, when x equals 1, this function is defined. When x equals 2, the function again is going to be defined. But now let's see what happens when x equals 3. So f of 3 equals 3 squared minus 9 divided by 3 minus 3. So in this case, we're going to get 0 divided by 0. And this one is undefined, so it's forbidden. It is undefined. So when x equals 3, f of x is going to be undefined. Therefore, f of 3 is undefined. So in this case, we're going to say x cannot equal 3. X cannot equal 3. Why? Because x being equal 3 is the singularity. Or we could say singular point. Both of them are the same. This means that when x equals 3, the denominator goes to 0 and makes the function to be undefined. But here, not only the denominator, but even the numerator goes to 0. Therefore, we're going to get 0 divided by 0. And whenever we get 0 divided by 0, in this case, the limit actually does exist, but it is not continuous at 3, and we're going to be talking about existence and continuity later. Okay. So, x cannot equal 3. However, x can be very close to 3. X can be very close to 3. Suppose x equals 3.0000001. How many zeros do we have here? 3 and 2, 5 zeros after the decimal point. And now let's see what we're going to get. So we're going to say 3.0000001 is going to equal -9, and here we're going to get so if we use a calculator, we're going to get almost 6. The result will be 6. Therefore, in this case, we say that x cannot equal 3, but x can be very close to 3. So it's a long statement. And we can come up with a mathematical notation for this statement to say that x, there's an arrow, approaches 3. And this means x is not equal to 3, but x can get very close to 3. And in this case, we're going to introduce limit. Limit x approaches 3, where we have x squared minus 9 divided by x minus 3. So this one means, this limit means x is not equal to 3, but x can get very close to 3. And we'll be solving more problems in the coming videos.